Good afternoon, everyone. Myself, Venkatesh. On behalf of Skill-Lync, I welcome everyone for the session today. Very nice to see 110 plus people have joined in the session. For those of you engaging with Skill-Lync for the first time, we are an engineering upskilling platform focused on advanced technologies across domains like mechanical, electrical, electronics, computer science, etc. Today's webinar is on Gen AI in automotive, transforming SDVs and intelligent mobility. This webinar is brought to you by Skill-Link's enterprise business. Our enterprise business focuses on employee training and upskilling across industries, including automotive, consumer electronics, etc. This is the 22nd edition of our corporate webinar for corporate professionals. Before we start the session, some pointers that would help us conducting this smoothly. If you have any questions you want to address Mr. Pratap, please post it on the chat window. He'll take it up during the end of the session. We will also share a feedback form towards the end of the session. Kindly spare a minute to fill it up. We will not be able to share the tech. However, we will be able to share the recording of the session if you request the same in the feedback form. Coming to today's session, it's my honor to introduce Mr. Pratap. Mr. Pratap is the practice head for software-defined vehicles and director of enterprise solutions at Skill-Lync. He leads the end-to-end vertical for solutions for connected cars and software-defined vehicles. He has over 13 years of experience in automotive projects with Continental, Veoneer, Marelli. He has a strong background in automotive product delivery, industrial automation, and business strategy. We are excited to host and hear from you, Mr. Pratap. Over to you.
Yeah, thank you. Thank you very much, Venkat. So let me be very clear. Is my voice audible?
Yeah, you are loud and clear.
Loud and clear. Great. Okay. So hi, everyone. Welcome to the webinar. So today we will be discussing about how do we leverage AI in general in software-defined vehicles. So right now, there's a huge buzz around about AI, and especially at the terms of Gen AI. So you'll be looking into it today. So let us step in. So the agenda is probably, I'm going to put it as a very brief agenda. So this is an overview session. Don't expect me to give you a complete, though there are some live demonstrations, I'm not going to take more and more technically because of the limited time frame. But generally, we'll go with this agenda. The agenda will be like, what is the difference between traditional AI and Gen AI? An overview of what Gen AI has to offer to us, right? Then how this particular Gen AI helps us in realizing features of SDV, and few live demonstration of certain use cases, especially one from ADAS and one from I would say one from ADAS and one from the infotainment system. So that's how we will take it ahead. I'll show you the live demonstration, okay? And then we will be looking at some Q&A. Right. So if the agenda is good, then let us go ahead and start the presentation. So what is traditional AI? So there's difference between the traditional AI and the Gen AI. So traditional AI is mostly specific. They actually master specific tasks, and they do have a particular task, and they have a clear agenda and a goal, a specific goal that they need to work upon. So this particular goal, whenever they are trying to work upon, they actually follow some kind of rules and algorithms, right? What are the rules and algorithms? As you know, that there's something called supervised learning, right? Unsupervised learning, reinforcement learning. So these three are different types of machine learning strategies, I would say. So these are the strategies that we generally use till now, right? For what? For your predictions, for your classifications, for your clustering mechanisms, right? So all these things we are going to use a traditional AI perspective. So this particular AI systems of machine learning, they actually follow the structured analysis and a logical processes. What does that mean? So that means that it has to have a structured data. The data should be a very well structured format. So based on that particular data and particular, even I think you have already seen that we are going to do the data extraction and data filtering as such, correct? So we need to do that particular process to make sure this traditional AI works. And how are we doing it? We have multiple models, multiple mechanisms like decision trees. You have your pattern recognitions, you have your predictive modeling, right? So on and so forth. So this is majorly on the traditional AI side. But what is traditional AI missing, and how the Gen AI is going to take that particular missing point? Whatever I have given in this red, right? Traditional AI generally lacks creativity and innovation, and it doesn't have that adeptness in handling uncertainty. So this is the I would say this is the big gap between why we are moving to this Gen AI right now. So this gap is quietly addressed by Gen AI by taking this particular information. So what it is trying to do, it is very good at innovation, and it is very good at handling uncertainty, right? So what is it doing now? How this particular Gen AI is working is, it is working. So the input of this Gen AI model, let us say that we have a Gen AI model. Okay, I'm just giving you what is the input and what will be the output. Our input will always be your large, I would say massive, structured and unstructured data sets. So these data sets can be numerical, these data sets can be text, these data sets can be images, data sets can be a couple of videos as well, right? So all these structured and unstructured data sets, this is the input for your Gen AI. And what is happening inside that particular model of Gen AI is a couple of neural networks undergoing this deep learning, as you all know. And finally, the output will be a new creative data that comes out as an output. Okay, so if you look into these 2 points, right? These two are the very important points, I would say. Probabilistic determinism of the next best token in this sequence, and also generate new responses. How does it generate the new responses? So what's happening here is, see, I just told you this thing, like that there's a model inside, you have all your neural networks, and these neural networks will do some computations, some mathematical computations, and give you a output, right? So how will that particular output will be determined is based on what is the input we are giving. Like, for example, if you consider all the new responses or all the new outputs what Gen AI is producing is coming from the pattern recognition from the pre-trained sequences. Just an example here. I think nowadays, Gen AI using ChatGPT, we are trying to come up with something called Ghibli Studio style, correct? So as you all know that Ghibli Studio is established in the year 1958, and the creator of the Ghibli Studio also told that this is he has put a lot of effort in this thing. A lot of his team has put a lot of effort to come up with that certain kind of drawings, which Gen AI has transformed everything and making sure that it gives you put any kind of image, it is going to give you a Ghibli style transformation. So why don't you think, I mean, just think about it. In that case, why does the creator of Ghibli Studio hasn't raised a copyright infringement? Right? Why he is not able to write a copyright infringement? The only problem with that particular thing is Gen AI model, like your GPT, ChatGPT thing, whatever you're using, it is only copying the style of Ghibli Studio versions. They say very clearly, if you go and look into the chat, the paper of attention is everything you need. That's one of the papers, technical papers, what transformers, it discusses about the transformers. So there they clearly say that whatever responses we are getting out, right? So those responses are trained on the pattern recognitions. That means copying the style. style of it, not copying exactly. See, whenever there is a how can we raise a copyright infringement? Whenever there is an exact copy of your work. But here what's happening? OpenAI is claiming that we are copying the style of it. We never copied your style of work. Sorry, your complete work. We just take the style of the creation and give the output. That's exactly what it means. Generating new responses based on the pattern recognitions from the pre-trained sequences. Okay, so that's one thing. And where are this Gen AI is being used right now? It is being used in automated content generation, AI generated art, that example of Ghibli style studio art, synthetic data generation, and content moderation. So what is synthetic data generation? Is fake data generation. Synthetic data is something called, we create a fake data that is an exact replica of the original data. But there is one drawback here in Gen AI. Okay, so the problem is the learning algorithms are complex, and because of that, so we cannot predict what will be the output. So it makes challenging to understand how some particular outputs are derived. So that's exactly the problem what Gen AI is focusing on. So right now there is a new development which is happening in the Gen AI field called chain of thoughts, COT. You can actually go ahead and look into the web as well. There's something called chain of thought where even OpenAI or Llama with the Meta, Llama models from Meta or the Gemini AI from Google. So they are actually working on this particular thing, like chain of thought. So how does that it happens is, now they wanted to make sure that they have to have a clear-cut reasoning. I think you are already seeing it in ChatGPT as well. There's a reason tab whenever you're trying to input something, right? So there is a reasoning, but how this particular reasoning is going to be used to generate that particular output, whatever we are looking into. That's exactly what this chain of thought means. That's what even most of the organizations are working upon it right now. Okay, so let us see now how the. So I just wanted to show you the complete picture of this thing. For example, so where are we at? We are at the, if you see the outer layer, there's something called artificial intelligence, as we all know. In that, we have a subset called machine learning, and in that, we have something called deep learning. And inside deep learning, we have something called generative AI. So whenever I say about machine learning, immediately you will come up and say, okay, there's something called supervised learning, unsupervised learning. You have your k-means algorithm, you have your random forest, etc., etc. These are the ML models that we are going to use. If I talk to you about deep learning again, it's a set of neural networks. In this neural networks, and we have some models, right? What are those models? Like CNN, convolution neural network, and RNN, recurrent neural network. So these are the different kinds of deep learning models that we are using till now. But we have something called Gen AI which comes up. Now, what are the subset of all this Gen AI? So let me start with something you already know probably, is LLM, right? So everyone knows what is LLM, large language model, correct? So that's exactly what even we call it as even the ChatGPT, right? Or Google's Gemini. So all these and Meta's Llama, these are all your LLMs, large language model, right? So is that it? Is that it? Or do we have multiple other models in it? What are the multiple other things we have in Gen AI? So in Gen AI, we have all these things. I'll just pause a minute here, pause a second so that you just have a look. Yeah, right. So I'll take you through one-on-one. I'll just take you through one-on-one, and I'll make you understand what are those models and how they were being made. So, but I just wanted to tell you that there are multiple subsets of Gen AI. So these are all your models. Okay. So these are all your techniques that will be used to provide the new generated output, what Gen AI is offering to us right now. So the best things, what all 99% of the population know probably would be LLMs, because that's exactly what you are hearing a lot many times when you are trying to have a conversation with any of your friends, or if you are trying to have a conversation with ChatGPT itself, you will say that, okay, there's an LLM, large language model. So what is meant by large language model? So let us break it down into different steps. Okay. So large means large data set. And one thing you must remember is large number of parameters. Like if you go and see some models, right? They'll say that, okay, 70 billion parameter, 70 billion, 80 billion parameter model, 60 billion parameter model. So what does that mean? So there's around 60 billion nodes, 60 billion neurons, right? So these are all parameters. I would say that, let us say this is a certain kind of mathematical equation which is there in a neuron. Let us think like that. What is language? Language is nothing but the types of languages what you're going to use. For example, you can use your English, what we are speaking right now, or your LLMs can predict the output in Hindi, in Malayalam, in Kannada, right? Then it can give it in even in Hebrew as well, right? So that's the nomenclature. We call it as large because of we use large data sets, large parameters inside it. There are multiple parameters inside it. So whenever I say parameters, think it of like a knobs, some kind of, I would say, let us say you are in a DJ setting, okay, the disco jockey setting, in a DJ setting where there will be a huge panel where you will be having a lot of knobs on it, correct? So based on the tuning those knobs, you will have your music generated. So just think that all your parameters, whenever I say, visualize them as your knobs. Okay, so that's exactly what we call it as large language model. In the same way, we have GANs, generative adversarial networks. We'll go into one by one. VAEs, variational encoders, diffusion models, autoregressive models, auto-generative, multimodal generative, RNNs, and neural radiance fields. So if you see multimodal generative model is nothing but a single model that can accept text, music, video, photo, anything, and it can generate that particular content. Okay, particular respective output. So let us go into a little bit into LLM. So let us see how this LLM works. Okay. So in order to in order to get to the basic model, basic foundational model of an LLM, what is that required? What are the steps that most of the organizations do? For example, even the OpenAI, right? They actually, whenever you see in the news, they say that, okay, when we try to build a foundational model that costs around $10 million or $20 million. Why it is happening like that? What does that mean? Whenever they say multi-million dollars of the capex amount they're trying to put in, right? Why they are putting it? Because large language model here, let us see step by step here. Large language model here requires enormous amount of information, correct? So how does this particular enormous amount of information comes in? And by the way, this information, whatever you are seeing in, is mostly all the information in the web. Okay, so it will be in terabytes of information, and not even terabytes, sorry, it's in petabytes of information. So most of the information came from the web. So I'm trying to show you here. So let us see how it will happen from step by step. So step one is download and pre-process internet. So what is happening here is we are trying to download this particular information from the web using what? Using web crawlers, and try to pre-process that complete information from the internet. So if you see here, there's a fine web pipeline which I have given here. So something like we will have a URL filtering, then you will extract the text. You have the language filtering, saying that, okay, it's in, see, some kind of website languages will be English, some will be German, some will be in Spanish, some will be in Arabic. So this language filtering will happen. and multiple other filters like offer, min hash, C4, custom filters. And finally, we have something called PII. PII removal is like PII means it's personal identifiable information. Like, for example, I would say it's like something like your Aadhaar card number, your social security number, your PAN card numbers, right? Your addresses, etc., etc. Everything will be removed. And we have a very nice clean data that's coming up from this particular step one. Okay. And how does this data looks like? It is coming from, see, for example, I have a website, I mean, fine web data set. I just wanted to show you that. So let me open it and I'll just show you this Hugging Face. So Hugging Face is majorly used. I don't know why it is. Okay, good. So Hugging Face is the web page where we'll be getting this data set from fine web, right? So this is all the data set coming from internet. Okay. This is, I would say, I will not say that it is a complete information, but it will be it is the best thing to start to train a foundational model. Okay, so you see the size of this data set, it's about 51.3 terabytes, right? Somewhere around 24 billion rows. And look at this, like you have your text, you have your IDs, you have your URLs and everything. So this is for training a data set. So for example, if you just look into this, so probably this is as big as this, like say something like what's happening here, how AP reported in all formats. It doesn't make any sense if you read it as well. It doesn't make any sense, but you can understand that, okay, there's some information which is happening. For example, this in all formats from tornado stricken region. Okay, so something like you have, it is talking about your cyclone called AP, or is it a newspaper? I don't know. Probably something like that. So it's all raw information, right? Getting into a different thing. For example, this is K-State put themselves in sole position of the first place in Big 12, 1799 over Iowa State on Saturday. So this is all the information. So how many rows were there like this? There is around 24 billion rows, right? So I just saw it here. Yeah, number of rows, we have around 24 billion rows. So there's a lot of rows in it. So you can just, it's available online. You can just have a look at Hugging Face Fine Web website. So this they will be using, right? So this they will be using to train your foundational model. This is exactly what it says. So now, once you have your foundational model, so what is the next thing? The next thing is what's happening? Just give me a second. Okay, great. So the next thing is, now we have all the text, right? Which you have seen it in the fine web data set, what we have extracted. So each row will be converted into sequence of symbols. Okay, because the model has to understand. So how does this understanding of this model will take place is you have your model information, all your text. This text will be converted into ones and zeros, as you know, right? So models will not take this ones and zeros for sure. They wanted some other information. That information is nothing but tokens. So this process is called tokenization, where you'll take this complete raw text and generate them into a sequence of symbols. And if you wanted to see how this thing works, there's something called tick tokenizer. Okay. So even tick tokenizer works this way. I'll just show you that. Okay, so look at this. So this is tick tokenizer. I think you're able to see it properly. Yeah, now good. So I just gave a simple system. So for example, I can write this is an SDV webinar, right? So this is an SDV webinar, let us say. Okay, so how many tokens it is generated? So this is the text. Okay, how this text came right now? It is coming from the extraction of your raw text from the internet, from the Hugging Face Find Web data set. Okay, so now this particular text needs to be converted into tokens. This is the process called tokenization. That particular information, once we get that particular information, this tokenization process will happen. And I'm showing you this example from Tick Tokenizer. So what is happening here is this is an SDV webinar. So what's happened here, the number of, the text, whatever we have entered is nothing but 17 tokens. And these 17 tokens are this. Okay, so now for each and every word, there is a number associated with it, right? For example, this has a number called 2500. Ease is 382 and 448. SDV is 14422. How is this happening? Absolutely no idea. Like, I mean to say that how the tokenization process will take place, it is a completely different process, but that's not the point of discussion for today. But this is how the tokenization will happen, and you will get one number associated with every word. So for example, if you wanted to see from this is an SDV webinar, if I wanted to just see this one, right? So, okay. So these are the number of tokens which are associated with this for all this. So for example, this starts with 2500 and the webinar ends at 1,33,794. This is the tokens. Okay. So now why are we talking about the tokens? Because this tokenization process is going to be helpful for us during the when I'm trying to tell you about the transformers, you will understand completely why this particular tokens are and how this is going to be converted into embeddings. Okay, so now great. So now what happened in this step is we have converted the raw text into symbols, sequence of symbols called as tokens, right? So now next, what is going to happen next? The third step of this particular training network. Now you have tokens, and the goal of your neural network, right? Because you need to now train the neural network. The goal of your neural network is to predict the next possible token. If you see the starting of the Gen AI slide, whatever I have shown, I told there that we need to predict the next best token. The next best token is your word, which you are looking at. Okay. So for example, now we are trying to predict the next best token. If you look into this example, right? So 91, 860, 287, 11579 are the token numbers of eye viewing single. Okay. So the next one will be 3962. What is 3962? It's post. So how does we get this thing? Okay. How does this is happening is by training the neural network. So your neural network has to be trained in such a way that your next best token should be the replica of whatever the text you have extracted before. So from that, you have to get the best output. For example, again, I just wanted to give you one more example. Like, for example, let us say bank, BANK. Okay. There are two meanings for bank. There are multiple meanings for bank, by the way. Okay. There's something called, it might be a financial bank. It might be a river bank, right? So let us stick to those two examples as of now. So let us say I am going to a bank. That particular word, that particular sentence, I am going to a bank, right? So this particular sentence will have ambiguous meanings. The reason being, I never said which bank. It can be a river bank or it can be a financial bank, right? But let us say there is a context to that particular sentence. I have withdrawn the cash, or should I say like this? I have to withdraw the cash. I'm going to a bank. So you got this information here. So there is a context understanding that I have to withdraw the cash. So from there, I need to go to a financial bank, not to a river bank, correct? So if the context of the sentence, the previous context of the sentence changed, like I wanted to go for fishing, I'm going to a bank. So what does that mean? The context says I'm going to go for a fishing. So that means that it should be the bank is nothing but a river bank. Right. So all this information, I'm just giving you a very clear, simple example there, neural networks will process this particular information. And there is a model which is called transformers that I am going to tell you in some time. So those particular transformers, right, it will help you to understand the context, whatever I told you before. That two examples of I'm going for phishing, I'm going to withdraw the cash. So they will actually understand that particular context to predict the next best output. That's exactly what you are seeing here in the neural network training. Okay, so now what will be the output of it? So this is the input sequence. Like what is the input sequence here? Whatever we are trying to give is multiple tokens, and these tokens will be fed along with parameters or weights. As I said, right, DJ, let us think that all your parameters, all your weights, all your biases in your neural networks, right? All these things, let us say that they're all your knobs, which you need to fine tune based on the input. Okay, let us think like that. So all the parameters and weights along with biases and your tokens will be fed into one giant mathematical expression to come up with a vocabulary size of these many numbers. Now, these numbers are again tokens that will be retransformed into the text, the output text, what you are looking at. So will this happen at one forward? I mean, one feed forward? Absolutely not. It will happen over the time. So that's exactly what we call it as a training. So it will happen over the time. Like we will be giving a lot of parameters. It will give the feedback. Again, the parameters will change here. Again, your knobs and dials will be changing. It will give a multiple other different kinds of parameter values and goes into this thing. Again, there's a feedback. Again, there is a change. So multiple times it will happen, and over the time, it is going to predict these particular vocabulary numbers. Okay, these are the numbers. These numbers are nothing but your tokens again. So these tokens will be transformed into text. Okay, so this is the third step of finding a basic foundational LLM model. Okay, now what's happened? Now what happened is whenever you have everything, you have the final step will be your inference, whatever I told you right now, right? That all your tokens will again come up with different numbers. Those numbers are nothing but all your tokens, and these tokens will be transformed into text. All right. So this is the basis of how an LLM foundational model will be working on. Right. And now we have this particular basis, right? I'm sorry. Okay. So this is the basis of how an LLM basic foundational model is formed. So now this model requires fine tuning from our side. Okay, that is custom fine tuning that we will do based upon our requirements. As simple as that. Okay, so we need to always look at this, like we need to find the basic foundational model. We have to get the basic foundational model right. Whether if it is an NLP task, or it is an image generation task, or is it a text synthesis task, or is it a image generation task or video generation task, right? You need to get your foundational model right. Then we need to fine tune it to come up with your own Gen AI outputs. Okay, this is exactly what I meant to say. Right, you have your foundational model right. Now supervised fine tuning will happen along with your reinforcement learning with human feedback. And what will happen here, right? This thing I'll come to you, why I have put this particular thing. So this is what's happening at the foundation model to come up with multiple enterprise LLMs. Enterprise LLMs is nothing but your whatever the large language models you're going to use in your organizations. Okay, now why did I put this thing here is something like I just wanted to tell you this, that in NLP, like for example, in natural language processing, where you are using these GPTs, GPT-3, GPT-4 in your chat GPTs, right? So what is happening over there is you get the text, but the way you have to get your text right. Like for example, if you open your chat GPT and you just say that I wanted to learn about foundational models, you get a clear text over there that high foundational models of this thing. These are the kinds of foundational models. This is blah, blah, blah. Like that, you will be getting a complete structured output. A foundational model, just listen to it very carefully. A foundational model will never be able to produce that kind of output for you, what you are looking at your ChatGPT. But what is happening over there is someone is sitting and writing their own human assistant programming. That means that they'll write how the answers should look like. Okay, like, okay, for example, I wanted to know about this large language models, right? So if I put it like that, so what kind of information should I, as a human, what kind of information should anybody want? Yes. The large language model is nothing but an used in, for example, like this. LLMs are nothing but large language models. Large language models are named because of they are using your large data set and also large number of parameters. And also it transforms into text, multiple text image. I mean, it can process into multiple languages from one language to another language. So something like that, I start writing it, right? There are humans, real humans, who are sitting and writing that. And they are going to give that information to the foundational models, so that the foundational models, again, the same Ghibli Studio style image copying. Foundational models copy the style of the persons who are writing that prompts and generate output, whatever you are looking into your ChatGPT right now. All right. So that's exactly what's happening with respect to the foundational models. And see, even you see OpenAI or Gemini or Google Mind or DeepMind. So they are also hiring a lot of people who are prompt engineers. So who will start writing these kind of prompts for all their foundational models. This is only for NLP, okay? This is only for natural language processing tasks. But there are human models, I mean, human writers who write it for description analysis, right? They also do, there are some artists who actually write their own kind of artist styles, etc., etc. So that's exactly what they are trying to do. There are multiple, they are hiring multiple human prompt engineers for NLP tasks, from video generation tasks, from art synthesis tasks, etc., etc. Right? So that's exactly what you wanted to understand to come up with the enterprise LLM that mimics ChatGPT. Okay. So now let us see what kind of LLMs we are using. Okay. So for example, I'll take very less time to explain this. So we have both infrastructure layer and application layer. In infrastructure, you have your inference, fine-tuning, hardware, and model creation. And hardware, most probably we are using NVIDIA hardware, right? NVIDIA, Habana, GraphCore, etc. And fine-tuning, again, you know these people, Google, AWS, OpenAI, Hugging Face. The same ones, the model creation also, you know, like OpenAI creates their own models. NVIDIA has their own models. Anthropic has their own models, like Claude 3, right? So Adapt has their own models. Even there are multiple things missing here. I would say Mistral, the French AI company, Mistral is there. DeepMind is there, who has come up with DeepSeek. So there are multiple model creations which are happening. Now, based on this infrastructure layer, we are going to create multiple applications. Like for a coding application, for all your coding things, right? You come up with GitHub Pilot. You have your code gen, you have Codiga, you have Mutable AI, right? In the same way, if for your chats or communications, you have Reply.ai. Okay, you have for dev tools, you have Dbuild, Replit. Replit is right now people are using. They are being used it for their CI/CD related informations as well. And you have your copywriting tools like Headline, Cohere, etc. So there are multiple tools that are there right now. So the ultimate aim for us is to make sure how do we utilize these kind of models in our regular work. Okay, I just gave you a side where when I talk about LLMs, I just gave you a side where you have your large language models, how this particular foundational model is implemented, correct? Now, I gave you other information that you have to be very strict in understanding how the foundational models look like and what kind of foundational models we need to take so that we can generate our own custom enterprise language models. Okay, so next, let us go into the next one. Just give me a second. Yeah. Sorry for this. Okay, 1 second. Just let me know if you are able to see the screen once.
No, Pratap, are you sharing?
Yes, yes, I'm sharing the screen. Yeah. Let me know now.
Yeah, it's visible.
Okay. Right. So there's something called GAN. Okay. So now we have learned about LLMs, correct? So now we have something called GANs, which is a subset of what? Which is a subset of your model, I mean, your GenAI. So these from now onwards, whatever I'm trying to tell you, all your GANs, all BAEs and everything are very much useful for our automotive industry. So let us see how it works. Okay. So there's something called GANs, which are nothing but generative adversarial networks. So imagine this. I will not go and tell you in a technical way. I'll just tell you in a uh, very open way where you can easily understand. So let us say there are two people. Okay. One is forger who forges the documents, who forges the images, who forges the signatures, someone like that. One is a detective. Okay. The one who detects that, okay, there's a problem. Now, this is a forger, right? So this is a guy who has forged it. So there are two people here. One is a forger, one is a detective. Okay. Let, let us call the forger as a generator, detective as a discriminator, right? So what is the forger doing? Is he is trying to forge many of the images. In our case, in our example, what you are looking at, forger has multiple images. He is trying to forge those images. Okay. Now there should be one person at discriminator level who actually discriminates this particular image and say that, okay, this is a wrong image. Okay, and try to send it back. No, this is a wrong image. I wanted to send it back. And the forger, what he will do, he will try to he will try to forge an image and he will send it out, send it to the discriminator. Again, the discriminator find, okay, this is the forged image. I don't want to accept it. Get out. It goes back. So this process is going to happen multiple times, numerous times in a neural network. At the ultimate thing, when the discriminator is not discriminator in the sense the detective, when he is not able to find out whether it's a forced image or not, then exactly at that point, there will be an output from the GenAI model. Hope this analogy works for everyone. So at that time, we are going to have a image coming up from that particular model. And this kind of information which is happening in the neural networks and this kind of model is called GAN, Generative Adversarial Network. And there are two types of GANs. Okay, these are the foundational models, as I said, style GAN 3 and vanilla GAN. Okay, I think by this time you could have sensed what is the use case, what is the use case of this kind of model. Probably, yes, you are right. It is ADAS, definitely, right? If you have your ADAS data set, definitely we are going to use this kind of model to make sure that we generate new synthetic data. As I said, synthetic is a fake data, which we are trying to do it multiple times so that the GAN model gives a realistic data, photorealistic data once we output that particular thing in the image, okay, from the model. So this is the concept of GAN. And where we use it, as I said, art synthesis, generation, and also the augmentation, where your original image will be horizontal flip. You can flip it, crop it, blur it, gamma it, or you can change your saturations, contrast this particular images. So all these things can be happen by using this particular GAN model. Okay, and you try these two things, GAN, style GAN 3 and vanilla GAN. Probably you will understand how to use this particular foundational models. Okay, so from now onwards, whatever I'm going to give you an example, it's the foundational model. And I know that you right now, you understand what is meant by foundational model. Okay, so next, that is one thing. So I have talked about LLMs. I have talked about GANs. Now I will talk about VAEs. Okay, same kind of analogy. Let us think in a different perspective. Okay, now I have some information. Okay, I wanted to zip it. I think you have your files, right? What you will generally do, you have a lot of files, you zip it. Why do you zip it? Because you will say that, okay, I can compress the image size. I wanted to compress those images and everything, correct? Because the immediate thing what you will look at is your size. Size will decrease, right? So let us say you zip your files and you send it to some other person, and that person unzip your files, right? This kind of analogy will work for your variational auto encoders. So where are we going to use this thing? Is we will try to use this kind of thing in your sensor readings. For example, there will be a large amount of sensor data that will be gathered by all your sensors. For example, your camera sensor, your radar sensor, your LiDAR sensor, right? Large amount of data will be gathered. So I wanted to zip some sensor data. Let us say your camera gives what? Camera gives images. I wanted to zip that particular images, and I wanted to send it to the destination. At the source, I will zip it. At the destination, I will try to unzip it. Okay. So what is going to happen at that time is, once you, there are two things which you need to understand. Once you zip it and you send it, so you are trying to save your bandwidth, you are trying to save your memory, you are trying to save your computations. At the destination end, what will happen is, once you unzip it, you will understand about the anomalies. So that is the most major application of this VAEs, anomaly detection. Okay, sensor reading anomaly detections. This is where we are going to use your VAE models, variational encoders. Okay, so generally what will happen, right, is you will have your VAE model, AI model. So you will try to feed in most of the healthy sensor data. Okay, whatever sensor data which we are live sensor data, you just feed in. Suppose, let us say we get some sensor values, some sensor data which is coming in, which is outside of this particular sensor data report, whatever we have already fed in, then immediately it will raise a flag saying that we have an anomaly here. The same kind of thing can be used for images, can be used for storytelling, can be also used for video generation. Okay, and how do we, what are the things, what are the foundational models which we can use? We have foundational networks from Keras and TensorFlow. And please have a look. You will understand more if you go into depth of it. Now, the very famous auto-regressive models where this is the transformers, I said. So auto-regressive models are used in your NLP task like GPT-3, GPT-4, etc., etc. So this thing comes up with multiple information. Okay. So this is a key components of transformers. Okay, this has, what are the different kinds of transformers? What are the different components of transformers? I'll just explain you on a very high level. Okay, I would say around 30,000 feet high. Okay, so now you all know what is tokenization, correct? So now you have your tokens coming in. Okay, so once you have your tokens, you will try to make sure those tokens were embedded. So what is meant by embedding here? So embedding is nothing but you are trying to come up with a matrix with a, we generally call it as a vector. So we are trying to come up with a vector of values. Okay, ranging from 0 to 1. And it is all integers again. I would not say it's 0 to 1, it is -1 to 1. Okay, it is all integers again. Okay, so how are we going to get it? Get these particular things is, sorry, not integers. These are all real numbers. So -1 to 1, that's the band gap where you are going to get the multiple vectors. So I would like to show you one script, what we have written. Okay, this is becoming a problem now. Okay. So look at this. Look at this. So I will just wanted to show you this thing and I'll take you to the next things. Okay. So you have seen the tokens, right? Whatever we have got, that this is a SDV webinar, and then I got some tokens, correct? So what I did is I transformed that into vector. So for example, 851 is this. 382 is ease. Okay. 448, this is a SDV webinar. This is exactly what I have given. And for that, some tokens we have got, right? So for each token, there will be a 8-dimensional matrix from where I'm going to have the numbers here. For example, let us say 851. 851 is this. The word this has been transformed into token called 851, and this 851 is going to be embedded in a certain vector like these things. So what are these values? We cannot know. We will never know what this kind of values will be. I mean, how we got these values, okay? But we can actually create a heat map visualization just like this using a tool called word to vector. And then we can create this kind of mapping where we can say this will be somewhere, see, the yellow will be 1, okay, and this one will be somewhere around 0. The deep purple will be somewhere around 0. Just think like that. Okay, so somewhere you are getting this kind of green. This kind of green is coming from somewhere here. So it will be something called 0.6 or 0.58, 0.57 or something like that. So you will have an embedding vector like this. And based on that particular vector, it goes to multiple steps process in the encoder and decoder using multi-head attention, normalization, and everything. And it comes out with a linear transformation. Okay, here again, there is something called logits calculation that I just don't want to tell you right now. And finally, you will come up with a softmax algorithm. So softmax algorithm is nothing but you're trying to convert your vectors again into something called probabilities. Like probabilities is always from 0 to 1, right? So you will get in terms of probabilities to find the next best bird. Okay, so this is not complicated, but if you are looking at the very first time, it sounds complicated. Okay, so my suggestion for you to understand the transformer architecture is please just have a look at this technical paper called Attention is all everything you need. Okay, that's the headline of that particular technical paper. Attention is everything you need. Okay, that particular technical paper is written by Google researchers. Just have a look. After that, only we started getting this GPTs, GPT-3, GPT-4, etc., etc. Right? But because that's the input for OpenAI to come up with this particular groundbreaking NLP models like GPT-3, GPT-4, etc. Okay. So the next one, we will be looking at diffusion models. Okay. So this is another subset of your GenAI. So diffusion models, again, you have multiple things. Now you have your image. So I wanted to generate a new image, right? How do I generate it? I will add some noise onto that image. And from the complete noise, whatever I'm looking at, from here, I will try to deconstruct this particular image from this particular noise and to find a different kind of photo or different kind of, different kind of image. Okay, so who are using these diffusion models? Stable Diffusion from stability.ai, DAL-E from OpenAI, and Midjourney from OpenAI. Right? So these are the foundational models, what they are using. Actually, I have a live demonstration for you at the end of this particular webinar. So you can have a look at that time as well, how the things are working. Okay, so what we did is we added noise to the data, iteratively applying transformations to a noise variable, generating high quality images, sound, video that resembles real world data. Okay, and finally, I have something called NERF. Okay, so I just wanted to say one thing here. Okay, to understand this, what if we give a bunch of pictures to you? Okay, a bunch of pictures like this, whatever you're seeing, that Lego blocks. Okay, and we ask you to come up with generate new picture of these particular images in any kind of any given direction, any direction. I just need, for example, I would like to have the right hand side or the left hand side pictures of this particular image. So I wanted to have it for a 3D video graphical quality or a virtual realistic probability. So that's exactly where I wanted to have this image. So what kind of model I'm going to use is this NERF, neural radiance fields. And how this will work is, I'll not go technical again here. I'm just trying to put you in a very open format. So what is the input? What is the output? These two things is what you wanted to understand. Input will be your 5D coordinate, like what is the spatial location plus the viewing direction. So XYZ will be the spatial location of that particular image. What is your viewing direction? Maybe from, if you are seeing this, right, you are viewing from the very front end, correct? So this particular direction I'm trying to give, and output will always be depending on the view dependent emitted radiation at that particular spatial location. So what is that emitted, what is that radiance that is trying to emit at that particular angle is what we will be trying to get it. So I'll show you an example here. Look at this. We have created this particular, this is actually again, it's a technical paper where we have taken this thing and we try to come up with a image calculation. But we are still working on it. So we got something with noise. So I'll just I think you're able to see it properly, that how this image is moving, right? So this image is moving like this because yeah, this is happening. This is a visual 3D realistic picture with noise, but we need to deconstruct the noise slowly, which our models are trying to do it right now. Okay, so it's still under progress. So how do these models right now? We all know these models right now, all these models. So how do these models help realize SDV features, right? So let us take the example of GAN only. I already told you this thing, like generator, discriminator, right? Detective, fake, forger. So what they are trying to do, they are trying to solve the problems of synthetic data generation for training, right? So these are the key problems solved, and realistic digital twins and AI-based image enhancement. And what are the enterprise LLMs using it? Like we have NVIDIA style GANs, which I have already shown you, the style GAN 3. And Tesla has come up with Tesla AI, which is a self-driving simulation. This is an AI model that works on GAN model. Okay, so Adobe Sensei is another thing. Adobe. So AI, it's again AI powered media enhancement. So we can also use this particular thing. And where and all we are trying to use this, we are trying to use this in simulating the traffic scenarios for ADAS. You can use it for enhancing perception systems, your rain fog simulation, etc. Right? And your VAEs, what I have shown you, your zip and unzip. As I clearly told you, zip and unzip, the best thing to use it at your detecting your sensor faults in SDVs, and compressed data storage for edge devices. Okay, so this is something which you need to understand. Like these are the open enterprise LLMs available. Your OpenAI DAL-E, right? Your DAL-E is this image to text synthesis, is using VAEs, okay, and your Hugging Face diffusers, they are also using this particular VAE models, okay, and transformers, RNNs, your autoregressive models, where your GPT, this I don't want to stress more, you know more than me what is GPT-4 is, what is Llama from Meta, what is Anthropic's Claude, and Gemini is from Google. So you know better than me how to use these kind of APIs. And we have a live demonstration at the end, how we are trying to use these APIs to come up with some kind of use cases. Okay. This is something which you already know. And diffusion models, as I said, we have from stable diffusion from stability.ai and Google Imagen AI, and Sora from OpenAI is used for video AI, right? So these are the things which we are actually using for SDVs again. Okay, so these are the diffusion models. So our live use case, right, that actually uses the diffusion model plus OpenAI, AUTOSAR regressive, auto-regressive model, OpenAI. Okay, so now, and you know where this NERFs are used right now. It is for 3D mapping for your autonomous driving, because you already saw that, right? We have created imagery of, it's a studio replica imagery of your Lego block, right? So how do we improve the LiDAR and camera fusion in SDVs and all? That's exactly what we are trying to do. So basically it is used for your 3D scene reconstruction with few images. Okay. So these are the main models which you need to understand. Now, as an organization, right? So do we need to create custom LLMs from the above models? This is the question everyone is asking us. Okay, because foundational models are already there. So what is this? How do we create your custom models? So we come up with three options: option 1, option 2, option 3. Option 1 says use your pre-trained LLMs and fine tune them. You have your foundational models, and also not only foundational models, there are some advanced models that are available in the market. Pre-train them and fine tune them. I mean, they're already pre-trained. Now you just need to fine tune them. That is one thing. The option 2 will be something like you create a custom LLM from scratch. This is highly time consuming. And you will know once we come into that, you will understand what are the steps that needs to do to create this LLM from scratch. And option 3 is your hybrid approach, like you fine tune and extend with custom components. Okay, let us see one by one option by one. So option 1, as I said, this is the fastest and most cost effective option as well, because you have your fine tuned LLMs already available like GPT-4, Llama, Claude, Anthropic, Claude, Sonnet from Perplexity. So you have your LLMs. Only need to do you have to use your domain specific data to fine tune those particular LLMs. And examples is like you are using OpenAI's GPT-4 to create an assistant, which you can use it for the diagnostic team, and you can actually fine tune some stable diffusion to generate synthetic road conditions, right? So this is an example which you will see at the end. The option 2 is nothing but it's creating a custom LLM from scratch. Again, it is highly expensive and time consuming. So you need to choose your architecture. Is it a transformer based? Is it a diffusion based for image generation? Or is it a 3D mapping thing? In that case, I have to go with NERF, right? You have to collect all your data. You have to train that model. You have to use high performance GPUs. You have to have it in your data centers, right? You have to pay a lot of money for that particular data centers to actually maintain them. Okay, and sometimes there will be a huge outcry that your GPUs are melting, just like Sam Altman has done for your Ghibli style studio creations and everything, right? So something like that. So, and you need to optimize this inference and deploy it in the on-premise or cloud. So it's a time-consuming process and it's a very expensive process. Now, coming to the third option, this is where almost all the organizations are trying to use this kind of approach. Like you have your fine-tuned LLM, good, I'll take it. And I have my custom components, good, I will try to integrate with my fine-tuned LLM. Okay, like usage is Tesla. Tesla is actually doing it. Using Tesla's FSD's perception model. FSD is nothing but full self-driving. That's one of the feature that Tesla offers. So FSD, that particular AI model is added with the GAN-based synthetic road training. So it can accustom to that particular roads as well based on the synthetic data that is being created, and it is fed into the model. So this is actually balancing. Ultimately, it is trying to balance most of the customization, cost, and speed. So the option 3 is mostly feasible option. This is what we as the link gives as a recommendation to any of the organizations. Okay. So what more SDV applications can be feasible using Gen AI? Now let us see some demo where you will be seeing some chat controlled vehicle assistant using, see, this is a chat controlled vehicle assistant using OpenAI and Hugging Face from Stable Diffusion from Hugging Face. So what I did here is I tried to, okay, let me open, just give me a second. Okay, so you're able to see a screen. Okay, so there's something called Chat Assistant Web UI. So what we have created is we have created the front end and back end for you to understand. Just wanted to put it in the web page so that you will understand more on it. So there's something called env. So it's an environment file. So generally what we did here is somewhere like, see, what we did here is we will be taking the OpenAI API keys and everything. Okay. Oh, it is opened in my other. Okay, just give me again. So it looks like this. Okay. So what is happening here is you have your OpenAI API key and Hugging Face API tokens. So these are to be generated in your OpenAI platforms. Okay. And by the way, if someone is going to try it, definitely you have to pay for this particular Open API key. Okay, from your side. It is, yes.
The windows are too small. Can you maximize or zoom in?
Now?
Yeah.
Okay, no problem. Because I just wanted to come up with the application itself. That will be a web page, so no problem. Okay, so okay, I just wanted to show you this environment file where you will be having this particular OpenAPI key and Hugging Face diffusion key, and you have a front end and back end. So now what I will do is I will try to run these particular things. Okay, so I'll directly run it and I'll show you here. Okay. So when I run it, right? Okay, before I running it, I just wanted to show you something called, see, the web page will look like this. Okay. So what we can do is we are trying to set the lighting of the car and also trying to set the dashboard visual of the car. Okay. What are the things what we used here? We are using React and React for the front end, React JS and JSX for front end, and back end we are using Flask. Okay, Python Flask, and we are trying to use the model API models of GPT-4 and Stable Diffusion 4. Okay, so now let us run this. Okay, just I'll directly run it because I'm trying to put it on I've extended the screen, so it's giving me a lot of pain here. So I'm trying to run it here itself and I'll show you how the things work. Okay. Chat assistant. Okay, do this here. Okay, great. Well, I'm directly trying to run this. Chat assistant. Okay, this is good. Now the front end is running. The front end. Start. Okay, now both the front end and the back end, both were running right now. Okay, this is the back end, this is the front end. So both were running right now. So I just wanted to see how whether my local host is up and running. Okay, now starting the development server. Okay, now Webpack compiled successfully and great. Now this thing is running for me. Okay, so this is the local host, which I think you're able to see it properly, correct? Now this is a chat controlled voice assistant, vehicle assistant, which I just created for our visual application. So what we are trying to do right now is we will try to set the interior lighting. So just imagine this. We are trying to set the interior lighting and dashboard visual via chat. In the similar way, we can actually try to enhance this particular application using not visual, using audio communication. Like you can use an conversational AI chatbot where you can just tell the car that, okay, you just do this, it is going to help. So for example, now I'm trying to set the lighting. Set the lighting to probably somewhere around purple and dashboard image to uh, breezy winter morning, or I would say photorealistic, because I just wanted to see a good image to breezy winter morning. Let us see how it works. Hope there will be no errors. Yeah, see, now I think you are able to see this screen. So the color was changed, as I said, right? We are using the color, the color was changed, and also the dashboard visual is set to breezy winter morning. So what kind of thing I have used here is I have used, let me directly show you that in that case, which one I have. Okay, see, for example, looking at the back end. So we have used this API, this app. Okay, code. Okay, great. Okay, so now if you look into it, right, we try to use this Open API keys. Okay, we are getting the Open API key from the environment variable, and we try to use the same things here, like generating the dashboard image. We are using this stable diffusion model, right? Stable diffusion version 1/5 model. This is one thing we are trying to use, and also we are trying to get the prompt here from the vehicle image, and we are trying to convert it into a JSON file. I mean JSON format. And this particular JSON format, we are trying to extract it and try to put it in to get this particular JSON dashboard image. Okay, and also the content. So this is one thing which I wanted to show you. This is one example. In the similar fashion, now let us see this. Now let us close these things and let us go. Okay. Now, the other thing what we can do is we can actually do the code generation. Okay. Code generation and software development. For example, automated code generation of your AUTOSAR or OS2 component generations, right? They can be, they can be done using this particular code generation software. Like, for example, even here, we can use the same Open API key and also try to generate your own code based on whatever input we are trying to give. For example, you can use this particular GenAI to, I mean, GenAI in the sense, one of the GenAI model, like your auto-regressive models of your chat, I mean, your GPT-3 or GPT-4 version to actually parse a DBC file, which is containing all the CAN messages. Okay, so you just need to make sure you choose a file in this particular web page, and you can just put your DBC file, and when you click a generate, you are going to get the complete. It will read, it will parse this particular DBC file, and it will create your own classes for you. Okay, so in the same way, you can also use it for your MBD tools. Okay, and you can also use it for your writing your Docker file manifests, right? Your Docker file manifest, your Kubernetes manifests, which are generated on the fly for all your SDV applications. Okay, so as I said, GenAI one of the model of the GenAI, like auto-regressive model, can be used to make sure you create your own code. Okay, this is one thing. The other important thing is your normal breaking. Okay, sorry, your test case generations. Okay, so it will help you to refine, decompose, and also you trace your system requirements. Okay, from for safety critical domains, like for example, your ASIL A to D. So whatever test case you are looking at is your SLD level test case, which is following the ISO 26262 compliance. And based on this test case, right, your GenAI application, whatever you're trying to generate, is going to read this particular information and try to come up with your own test cases. Okay, you understood what I tried to say. So basically what it will do is it will do all your consistency checks between these requirements, between your architecture and between your code as well. And it will give you multiple test case classes with all your functions inside it. Okay, and then you can start writing your own code if you wanted to make any kind of changes at the boundary level or at your state level or your at any of your class level, etc. That there you can actually make that particular changes, right? And now I just wanted to show you something very interesting. Okay. This is called pedestrian night scene in fog. Okay, what you're trying to do is you have your input, right? You can actually generate synthetic sensor data, which I already informed you previously. Like it's a fake data only, but this data is going to make sure that it is generated using the realistic data to be a realistic image, but this is not available outside. It is generated image. So this kind of images, if we generate multiple sets of images, they can be fed into the your AI related models, where they actually take they can be trained for any kind of your ADAS AI models, etc., etc. For example, you can use your Gen AI in a scenario generation for ADAS validation in virtual environments. Like, for example, if you are using Carla, if you are using NVIDIA Drive Simulator, you are using IPG, definitely you can use this particular thing. Okay, so they also assist you in writing unit integration and regression test scripts automatically. And let us see the example. It will try to analyze log data, etc., etc., also by auto generating defect scenarios. Okay, now let us see an example here, which I would like to show you in a live demonstration. So again, I have written we have written the code in this one. Again, something like in the SDV apps, probably, yeah, pedestrian night scene. And again, here we have your backend and front end. The only thing you need to do is you have to run it. So how do you run this particular things is let me run it again as I have shown you previously, and we'll come back to this. Okay, command prompt. Let me run the backend first. Okay, let me do one here. Let me run the backend. Okay. You have the same Python scripts there at the backend. And you have the same front end script, but in a very different front end script again. Okay, so I see that you are trying to see the developer center, development server, which is going to run, as well as your front end is going to run here. So just give me a second before it runs right now. Okay, so front end is running. Okay, great. Okay, got it. Now this is the scene which you can generate. Okay, so there's something we have given this. This is hard coded, by the way, even in the code, but generally this can be a user prompt where you can ask saying that you create a data set of images. Okay, but just for the this webinar purpose, we have created this pedestrian night scene in fog. It's hard coded in the code itself. So when we create generate scene, what is going to happen here is we are going to get an image as well as description of that particular image, like what is happening in that particular image. Okay, so all these things you'll be getting it here. So this is something like you can create multiple data sets like this for your ADAS simulation and take this particular data set and put it in your AI model for training. As simple as that. Okay, so let us wait until we get that. Yeah, there's some image is getting generated here. Yeah, I think yes. So there's an image generated like this. Okay, and I have used the stable diffusion here. That's the LLM which I have used. That's the API which I have used to come up with this particular image. And this is the image. So now they have to describe about this image, correct? So who is going to describe? And it has given a description. On a most peculiar night, an urban street lay shrouded in an ethereal blanket of fog. Okay, a delicate moisture kills the air, blurring. Oh, great. So based on this information, right, if you give this information to an NLP model like GPT-3 or GPT-4, and you give an instruction to it saying that I only require information that is pertaining to understand whether there is a girl, I mean, whether there's a human being or not, it will directly give it to you. Okay, you just need to give this particular description to that particular model and it will directly give that information to you that whether you have a girl or not, because this is all English literature which it has generated, right? I don't know where the girl or someone echoes rippling. I don't see any. They stood like white sentinels. Okay, this I don't know where is that. At least there should the pedestrian embarked on the wet crossing. Okay, so this is important for information for me, right? So if there is a pedestrian, that is good. So this whole information from this, it can actually try to get that information as well. Like, okay, there's a pedestrian. And also what is the environment? Environment is nothing but your car headlights glowed like distant lighthouses, right? That means there is a glowing image that is happening here. Distant lighthouses, the car image is being shown up like that. So all this information can be fed up again to an LLM and come up with the JSON format where you want, which is the information you really require for further processing in ADAS applications. Okay, so this is one more thing which I wanted to show you. And going to the next one, right? So we have DevOps and continuous integration. Don't worry, I don't take more than 5 minutes from now. So this is DevOps and continuous integration. So we can use GitLab and Jenkins APIs as well. And we have something called N8N workflow management. I don't know how many of you know this thing, which is called N8N workflow. This is used for workflow automation. And this is a very famous tool right now, just like Make and Napier. N8N, which we are trying to make multiple workflow automations where we can actually take the input from GitLab, or we can take the input from Jenkins, or we can also do one thing. We can create automated generation of emails. We can create automated. It is the limit. The use cases of this particular N8N is limitless. Okay, so we can use that for your GitLab and Jenkins workflow management, especially in terms of DevOps and CI/CD. And the data-driven development, yeah. So what is happening here is we have sensor data. We are going to get a lot of sensor data, and your VAEs, if you remember, variational autoencoders, that model is trying to find out what is the anomaly in the sensor data. It is going to collect all the data which is found good. Okay, and it will try to zip it and blah, blah, blah. You know all these things. Now it is going to collect a lot of information. So once we have this information from multiple sensors, multiple sensors like ADAS or LiDAR or radar, etc., etc. So now we need to make sure we summarize this to come up with a general insight for any kind of optimization, even though it's a HVAC optimization or it is some other optimization, we can actually try to generate insights. So how do we generate insights here? We generate insights using your natural language, correct? Everyone knows that it has to create a report. in natural language where people can understand. So what kind of model can be used over there? Yeah, right. So it is like your GPT-3 model or GPT-4 model, right? These are the models that we can actually use to come up with this particular data-driven development. Okay, so you got this data. So now it's very simple. Imagine like this: sensor data, healthy sensor data, live sensor data fed to a VAE model, come out. The output is nothing but the uh, right data, not the faulty data, because all the anomaly detection will be done by the VAE model. And this right data will be fed to the NLP model to get out a report saying that this has happened between this times. Okay, this is what it meant about data-driven development. And yes, so the last slide is, I think, this is the best slide, I think, in the whole presentation, probably. Yeah, so thank you very much. I think please reach out to us if there is any questions. Probably Venkat will be helping you in understanding a few of the things. Oh, and also just one more thing. We have a lot of programs. Skill-Lync has a lot of programs in Gen AI where we have created multiple synthetic data sets. We will let you know and we'll teach you uh, how to use AI models. Okay, see, guys, I'll tell you. Nobody is asking you, especially in automotive sector, nobody is asking you to come and create a foundational model. Okay, the option 3, which I have shown, is the thing which is going to go forward for automotive industry, to be very specific. Okay, so once we are trying to tell you about the option 3, where you will be using your custom GPT as well as your custom components which you are going to create, that should be integrated with your enterprise LLMs which are already present in the market. So what you wanted to know is you need to understand how to integrate all these things, how to use your AI tools right now. That's very, very important for your SDV application development going forward. So we have multiple courses on this. So please reach out to us. We have courses on Gen AI, as well as we have courses on agentic AI, where we are going to create an AI agent using N8 and workflow tool. So we can actually try to help you in multiple understanding, and you can actually use this, take this particular concepts and try to use it in your work and get more productivity out. Okay, so that's the aim. That's the day for us. And thank you very much for. I don't know how many participants are there in the call, but I hope there are a lot of participants probably. But yeah, I think thank you very much and good day. Yeah, yeah. Thank you, Venkat.
Thank you, Pratap. There are no questions as it is. Only one question from Biju. Mr. Biju is there. How can organizations how can organizations share their data with enterprise LLM for processing, like in the option 1?
Okay, see, enterprise LLMs, that's exactly the other thing which you need to, that's a drawback right now, that many people, they are actually looking at like, okay, we have enterprise LLMs, but what if we share it to with anybody? Can we share our organizational data? That's option 1, correct? But what we said is we need to go with option 3, that take the custom LLM, take the enterprise LLM which is available to you, try to integrate your custom LLMs into that particular enterprise LLM which is available, right? That's the option 3. So now you are not going to expose any of your organizational data to the outside world. You just need to buy that enterprise LLM and try to, that API, and you are trying to use it in your own organization, right? So in that case, that will be a feasible idea.
Yeah, hope that answers your question, Mr. Biju. Folks, we'll keep the chat window open for another couple of minutes. If there are any more questions, kindly share it. I have also shared the feedback form in the chat window. Please take a couple of minutes to fill it up. It will help us improve our offerings to you.
Thanks, Biju.
Pratap, I don't see any other questions. If there are anything posted, we can do it off the call. Thank you so
Sure.
much for your time. And thanks everybody for joining in.
Yeah. Thank you. Thank you, team. Thanks for joining in.
Mr. Biju has a follow-up question.
Yeah. These courses that you mentioned is for people without IT background. So yes, without IT background, so I don't know what is your background, Biju, but probably please reach out to Venkat based on your requirements, so we will get to know what it is. Okay, then we can give you more information.
Mr. Biju, there is a question in the chat window. Kindly fill it up. We will get in touch with you off the call. Mr. Pratap, there is a question from Bharadwaj. Do we need some extra infrastructure if we use fundamental models available?
No. Extra infrastructure. See, you have your foundational model already built with foundations from OpenAI or Google or DeepMind, from wherever you take, you already have it, right? So I don't think you just require to put more infrastructure into it. See, it all again, the expensive part is over. The most expensive part is already taken care by OpenAI or Gemini or whatever it is. But right now, what is your requirement from here? Whether it depends or not, it is all tailored to that particular response. Hope I have answered your question. Okay. AI can be used to detect feedback mechanism in the functionality like region and suggest best solution. Is it a statement or is it a question? Okay, say it again. AI can be used. Okay, can AI be used? What is it? Can AI be used to detect feedback mechanism in the functionality like a region and suggest? Yes, of course. Have you tried GitHub Copilot, Arun? It will let you know while it is used as a peer programmer right now, right? It is actually integrated in your Visual Studio Code as well. If you're trying to write your code and yes, correct, Copilot, right? So if you are trying to use this Copilot and you try to, that is actually used as a peer programmer, and it will suggest you what is the best solution. If there is any error, it will let you know on the fly that, okay, there is going to be an error because of the statement. There will be a runtime problem. There will be a runtime execution. Yeah, that is what Copilot is doing. And of course, yes.
Thank you, Arun. Thanks, Mr. Pratap. I'll give it a couple of minutes and close the session. Thank you for your time.
Okay, sure. Thank you. Thanks, team. Thank you very much.